Hi, this is Wayne Odegard, and I'm with Aviation Laboratories, and this morning I'd like to talk a little bit about why we do oil and oil filter analysis in aviation engines. So the first thing we should know is that when we look at oil and we look at oil filter, we're trying to proactively find abnormal wear. We're looking for abnormal wear, that kind of wear that's going to create problems, either mechanical problems that are going to require a major fix or overhaul, or safety problems, so that we can catch those things before they become serious, before they become deadly, before they become expensive. So that's what we try to do with oil analysis. But there's a difference between oil analysis and oil filter analysis, and it's important that we understand what that difference is. With oil analysis, we just take a sample of oil and we look for elemental metals, transitional metals mostly. We're looking for iron, we're looking for copper, we're looking for chromium, and because it's elemental analysis, we don't necessarily know where those are coming from in the engine. We just know that they're coming from the engine. We like to say every engine makes metal, which is true. You're going to have a baseline of these wear metals in your oil all of the time. What we're trying to detect is abnormal levels of those wear metals. Obviously, if we're looking for changes in wear metals in oil, we're also interested in the trend, because the more data points we get, the more obvious the changes become, and the more dramatic the changes become if they're abnormal. So it's important for us, when we talk about oil analysis, to recognize that the trend is the most important part of that, and to get a good trend, you should do it at least every oil change. Okay, so let's talk about filter analysis. With filter analysis, we're not looking at the oil now, we're looking at the debris that's been captured in the filter. And the debris that we capture in the filter, some of it we can see, some of it we can't see. So the same purpose applies. We're trying to find abnormal wear in the engine. But whereas with oil analysis, we're looking for elemental wear metals, with filter analysis, we can see actually solid. We can see the chips that are coming from the engine. But I'd like to make one point about filter analysis. There's a difference between the filters in a piston engine versus the filters in a turbine engine. In a piston engine, because the pore size of a filter, a typical filter, is 30 or 40 microns, that means the holes that are in the media in the filter itself, a lot of the wear metals flow right through that filter. The smaller wear metals flow right through that filter. So for us, the piston engine oil analysis is the more important analysis. A turbine engine is different from that. Because the turbine engine isn't exposed to the same kinds of combustion byproducts, dirt, debris that a piston engine sees, the pore size of a turbine filter can be much smaller. It can be 4, 5, 6 microns in size, in which case most of the early warning signs for abnormal debris get caught in the filter. So when you look at oil analysis for a turbine engine, you don't really see a lot. The data is in the filter. So when we're talking about pistons, we like to do oil analysis every oil change. When we're looking at turbines, we can still do oil analysis, but it's really important for us, because most of the data is in the filter, that we do filter analysis as well. But in either case, what we're trying to do is identify abnormal wear before it becomes an expensive or safety type problem for you. Hi, this is Wayne Odegard with Aviation Laboratories, and I'd like to talk a little bit more about oil analysis. In a previous video, we talked about the whys of oil and oil filter analysis. In this video, I'd like to talk about how. How do we do oil analysis? How do you get it to us? And how do we process it once we've got it? The first thing I should say is that when you buy a kit from any of us, any of the labs, particularly us, this is the kind of sample bottle you'll get. It's a 2-ounce sample bottle. It's safe for shipping. It's safe for going through the postal system. You buy a kit, it's empty. It basically has this in it, and it has a piece of paper in it that you fill out that gives us all of your information. Okay, so you get the kit, you're ready to change your oil, and you want to do an oil analysis. So you open the kit, you check out the sample bottle, you drain some of the oil when you're draining the oil out of your engine, and then you catch sort of midstream, catch enough oil, try to fill this up, and close it up tight. Put it in a plastic bag that's in the kit and seal it up and send it to us. Before you seal it up, however, we need you to fill out this piece of paper for us. We call this a customer information form, and it basically includes 3 sections of information. The top section is your contact information. That's the information that we'll assign with the sample when we get it. The middle section here is a sample about your engine and about the oil that you're sending us so that we know more about that. The bottom section down here is if you've done any special maintenance on the engine that you'd like for us to know about, if you use an FBO or a mechanic shop that you might want us to know about. All of that information goes in the bottom. Make sure you fill this out completely. It's part of the evaluation that we do when we look at your oil, so it's really important for us to get this complete. So you put this in with the oil filter, put it back in the box that it came in, and send it to us. There's a shipping label in our kit to send it back to us. Once we receive these samples in the lab, we get hundreds of these samples every day. So once we receive the kit in the lab, we actually open the box, open all the boxes, and assign a control number to both the CIF and to the oil sample bottle so that we know that these two go together. Our clerical staff starts to enter this data into our computer while our technical staff starts to work on the analysis of this. So we have hundreds of these that come in every day. So because we have a control number assigned to them, we enter the control number into the computer. It's recognized by our ICP. So when we do the analysis, we can mesh all of those things together. All right? So the first thing we do with the oil sample that you've sent us is we draw out a small amount of it. We put it into a test tube that looks like this. And we put some solvent in with it just to dilute it so it's easier for us to get it through the instrument. So the diluted sample now is put on an auto sampler in our ICP, our inductively coupled plasma mass spectrometer, and the instrument draws that sample into it through this peristaltic pump here on the front of the instrument. It draws into here, flows up here, flows across a flame. What the flame does is it basically atomizes all of this oil. So all of the wear metals that are in the oil are atomized. We have detectors here that pick up the energy from this process, and they evaluate the energy. They evaluate it for 2 things. They look at the wavelength of a particular metal. So every transition metal has a slightly different wavelength when this process happens. So it picks up on what that wavelength is, but it also picks up on the strength of that wavelength. The strength of the wavelength tells us how much of that metal is in the oil sample. So we've got the sample through the instrument, do the process of atomizing that oil sample to pick up the wear metals that are in there, the type and the concentration, and then that data is dumped into the data processing cycle, and from that we merge that information into our laboratory information management system, our LIMS system, and then we can evaluate that within our LIMS system. So how do we evaluate that? We look at all of the wear metals, 12 or 15 wear metals that we're actually looking at, and we look at your sample's data versus all of the samples that we have in our database that are the same engine type as yours, approximately the same number of engine hours as what's on your engine, and the approximate oil hours that are the same as the oil sample you sent to us. And we use those three parameters to grab all of the data in our database that match those three criterion, and then we compare that average against your specific data to tell you whether or not your engine's making more metal or making less metal against the average. And that's the first thing we do. That's a comparative statistical analysis that we do. The second thing that we do is the much more important part of that, and that's to compare the trend that you're doing. So we look at the last sample or the last several samples, if we have any, and we compare that to the new sample. So if the trend is going up, we note that. If it's going down, we note that. If it's staying consistently the same, that's a good thing. We also note that. And we comment on that. If it's going up exceptionally up, we'll make a comment about where we think that metal might be coming from and what we suggest you do to proactively address what looks like a growing problem inside of your engine. And we do that for all of the metals that we've tested for. We look at all of them. We look at the averages of all of them. We look at the trend of all of them. And we comment on what we think is happening in your engine and where that thing might be happening in your engine. Right? So we use comparative statistics. We use trend analysis. The third thing we do is that we look at it more of a holistic kind of approach. We say, even though you may have these slight anomalies in the sample data that you have versus previous data or versus the average data, even though you may have some anomalies, they may not be a problem. So we have an overall, we call it an alarm meter, that tells you, your sample's green, sort of like a stoplight. Your sample's in the green, it's yellow, it's a caution, we need to be watching, or it's red. We've got a problem, we've identified a problem, you need to proactively deal with this problem. So you can look at individual data, you can look at the comparative data, you can look at the trend data, you can look at our comments about the sample and what we think the data means, and if you're not interested in any of that, you can just look at the little stoplight that we have up at the top, green, yellow, or red, and it will tell you whether you need to be concerned about the data that we've received for the sample. Okay, so we've received your sample, we've tested your sample, we've evaluated your sample and presented all this data to you. How do we get that information to you now? There's two ways that we do it. The first way is we just send you an email. We've got your data, we'll send you a PDF file of the results, the last 3 results if we've got them, or however many, up to 3 that we've got. We also have those available on our website. And those samples, once they're on our website, they're always on our website. So for the oil analysis, we use the engine serial number and the customer code, which we'll assign to you when we get your sample. So you can always go out to our website. You can type in your customer code and your engine serial number, and all of the data from all the previous samples will be there. We've got some graphic capabilities, so you can go in and you can graph things. You can put in things like compression data if you'd like to, so you can compare one to another. You can isolate specific wear metals if you want to, or look at them all at once if you'd like. There's a lot of capability on our website. So even though you get this email, and it's got the PDF file, which you may want to print, put in your logbook or in your records for posterity, you can always look at those online as well and keep up with them that way. Okay. The last thing I'd like to say about this is that you probably will have questions from time to time about what your results mean. There may be something that we say that you're unclear about, or you talk to a buddy and his experience was somehow different than yours, so you may want to address that with us. You're always welcome to call us. Our lab manager is available at all times. We have a trained technical staff that's available. I'm available to you as well if you'd like to talk to us. Please do give us a call. If you like this video, even if you don't like this video. Leave us a comment below. Let us know what you think. If there's something that you think is important that we've missed, please let us know that too. And if you're interested, we'll be doing these from time to time, so please do subscribe to our channel and keep up with all the latest news we have. Thank you.